Hi everyone and welcome to this lecture. After finishing up with the Python lecture, we now embark on learning machine learning. The first thing we're going to learn about machine learning is the general pathway. First, we'll look at the general idea of how a machine learning pathway looks like that leads to a direct impact on the real world. In the process, we'll also define roles in the data field, including data engineering, data analysts, data scientists, machine learning engineer, etc. We will cover most of this in the course itself, so don't worry if you don't completely understand what it is, but this is just giving you a general pathway of how machine learning moves from the real world to creating impact in that real world. Note, there is some definite overlapping of most of these roles, as we will see when we look at this pathway. Let's look at the pathway. The first thing that we usually have is the real world, which we generally live in. Then there are a lot of situations that we might encounter, but we will deal with these two situations where these are questions to be answered and there is a problem to be solved. These are the two situations that are involved in machine learning. Generally, we can just label this in two, where we're just looking at answering your questions where we're looking at if X has an effect on Y, and if you're solving a problem, we're looking at how to change X. For these two situations, we have data analysis and data product. These are data analysis that will be done, or there's a data product that will be produced. Data analysis basically deals with reports, visualizations, and communication, where we look at data and create reports and visualization and communication which can help the real world. On the other hand, data products deals with web applications, softwares, dashboards, where you create a web application which uses data to try and solve a certain problem, or have a dashboard that helps have and or show how to fix a certain situation or certain problem, or how to fix or change X. These are the two distinguishing features, but these are general overlap between them, because a good data product usually has some visualization in it, a good dashboard has some reports in it, etc, etc. But we'll look at them like that, as data analysis and a data product. So generally what you're going to look at is see how data can come from the real world to produce data analysis or data product, and this data product or analysis have an effect on the real world. So let's start. The first thing that comes out of the real world is data, and this data is usually raw data. This data can come from various things like surveys, login systems, simulations, etc., where surveys are basically like questionnaires that are given to people and they produce the raw data. Login systems are, for example, a social network site like Facebook. Once you log in and share your pictures and like, etc., this produces raw data. It can also be not directly from the real world, but from things like simulations that help in self-driving cars, which use mostly simulations, and video games, etc. And once we have this raw data, the next step is to know how to process and store this data. Data can be stored in various ways: in Excel files, SQL database, a CSV, which is basically a comma, separated values, cloud storage, etc. You remember the cloud storage that we talked about in our basic and most fundamental concepts lectures. Depending on the data that you have and the amount of data that you have is what will determine where you will store this data. These specific roles are done by the software engineer, where he takes the data, processes it and stores it in a perfect way. And data engineering also involves some bit of cleaning, etc., but these are basically what a data engineer does. Let's collapse this raw data and processing and storing data to one specific box here and call it collect and store data, so that we can have some space. Once the data has been collected and stored, this data has to be cleaned and organized. This mostly involves restructuring the data, dealing with missing and overlying values, restructuring the data, etc, etc. What dealing with missing values is very important, because once you have this data, you have to know what you're going to do with the missing values, the heavy outlying values, the outliers, how you're going to restructure this data, how you're going to do some feature engineering, how you're going to do all these things, organize the data so that it works. Remember, most of the machine learning algorithms you're going to learn requires your data to look in a certain way. Like for example, if you have two countries, USA and Kenya, you cannot feed a machine learning algorithm with the USA and Kenya. You have to do some encoding of this data to have probably Kenya represent 1 and the USA represent 0, or do some dummy variables where you have USA. If it's not USA, it's 0. If it's USA, it's 1. You have to put this data in a structured or organized way in such a way that your machine learning algorithm will understand what it's supposed to be doing. The restructuring, dealing with missing data, outliers, etc., it can be done when the data has been collected and stored, and this cleaning and organization part can be synced together if you're dealing with a good data engineer. So as I've said, there is a lot of overlapping of these roles. The next thing you want to do after you clean and organize the data is to do some exploratory data analysis, where you just look at the data and try to find out, what does this data require? What does this data say? What is the information that I can extract from this data? This usually involves using visualizations and statistical analysis, and in Python, visualization is usually done by matplotlib, which you will learn, and Seaborn, which you will learn, and statistical analysis is usually done by pandas, which we will also learn. So you just check and see if there's anything of importance that comes from this data. The cleaning and organizing the data and exploratory data analysis is what is termed generally as data analysis. Data analysis is usually done by the data analysts, or in some organizations they're also called the data scientists. Remember, these roles are usually interchanged depending on the organization that you are working for, because in some company a data analyst does the same job as a data scientist. Once you've done this, you have to ask yourself a question. What are you trying to achieve? If you're trying to answer a question, a specific question, then you are trying to deal with purely data analysis, and with that, with whatever we have here, this will be enough. Because once you have collected the data, cleaned it and explored it, and doing exploratory data analysis with visualization and statistical analysis, now you can create reports and visualizations, and this can be used in the real world directly, as it has answered real world business questions. For example, if you are trying to answer on why a certain product has failed, and you have already collected the data, cleaned it and explored it, and understood what is causing a certain product to fail, you create a report and visualizations and return it to the real world, having answered the real world business question. However, if we want to continue and get involved in creating a data product, we can now embark on moving forward. In that case, we move on to the next step, where we are creating machine learning models. There are various machine learning models, where they are supervised, unsupervised, and reinforcement learning. But we will deal with unsupervised and supervised learning models. For a supervised learning model, we basically deal with trying to predict a specific outcome. While with unsupervised learning, we are trying to discover specific patterns hidden inside the data. For predicting an outcome, you might want to predict an outcome from a certain data point, trying to see how the future sales might be of a certain product given some existing metrics. While discovering patterns in the data involves looking generally at the data and trying to see if there is a pattern that can be derived from the data that can be very helpful in the real world. These roles are usually done by the data scientist and machine learning engineer, because for machine learning to happen, there is some exploratory data analysis that is done to realize how the data looks, and then there's the creation of machine learning models. This is basically machine learning, and it is done by the data scientists and the machine learning engineers. Once you create a model, you can do various things with it. You can create a software, you can create an application, which can be either a phone application or a web application. You can also create dashboards. These things are usually overlapping, since once you create an app, it can have a dashboard inside it, and once you have a software, there can be an app version of it on the web, etc. And that's why we put them together and say this specific thing that comes out of that is the data product. This data product helps in predicting the future and outcomes or gaining insights on the data. These data products are becoming increasingly useful in the real world. What we will discuss in this following course is we'll look at NumPy and pandas for the data analysis, look how to clean the data, organize it, do exploratory data analysis by creating visualizations with things such as Matplotlib and Seaborn, etc. And then we will embark on looking at machine learning algorithms from supervised to unsupervised, understanding the various supervised models which involve linear regression, logistic regression, etc. And when we look at unsupervised learning models, which we will have things like k-nearest mean, etc., etc. Fun times ahead. I'm very excited for this next part of the lectures. See you in the next one.